Welcome back to Mr. D's Please Physics Tutorials. Today we're going to go over the questions for the Chapter 3 review test. Question number 1. Which of the following is an example of a vector quantity? Now a vector has two components to it. It has magnitude and it has direction. So you have to look at the possible answers and choose which one has magnitude and direction. Alright, hopefully you picked velocity, because velocity is displacement over time. Displacement has magnitude and direction. Alright, number 2. Identify the following quantities as scalar or vector. The mass of an object. The mass of an object would be in kilograms. The number of leaves on a tree, that would be like a number like 5,300. The wind velocity. Now the key word here is velocity. Velocity, remember, is displacement over time, and displacement has magnitude and direction, so it's this vector quantity. So choose your correct answer. I hope you chose C. Mass of an object is scalar, has no direction. Number of leaves is scalar, has magnitude, no direction. But wind velocity, velocity is the key. It has direction, so it's a vector. So C is the correct answer. Let's go to the next one. Alright, let's look at number 3. In a coordinate system, the magnitude of the x component of a vector and the q, which is the angle between the vector and the x-axis, are known. The magnitude of the vector equals the x component, and you need to finish the sentence. So, I'll give you a hint here. This is the key word right here. They want you to find the magnitude of the vector, not the x-axis. They told you know the magnitude of the x component of the vector. So you don't have to find the x-axis. So you want to find the magnitude of the vector, which is the hypotenuse. So take a moment, see if you could figure it out. Alright, this is a tough one. Not only did you have to know your physics, but you also had to decode what they were asking for. So, if you remember, cosine angle is adjacent over hypotenuse. So that's ka for SOHCAHTOA. Now, we know that the adjacent in this instance, based on the information given, is the x. So the x over the hypotenuse is cosine angle. Now, they wanted you to find the magnitude of the vector. So the vector in this situation is the hypotenuse. So you want to get this by itself. So remember, you can switch the denominator on one side with the numerator on the other, and so now it becomes hypotenuse equals x divided by cosine angle. So you did this by cross cancellation, so this is your right answer right here. So it's x divided by cosine angle, so the x component is divided by the cosine of the angle. They use q instead of the angle symbol because the keyboard doesn't have this angle symbol. Alright, let's go to the next one. Alright, number 4. Which of the following exhibits parabolic motion? So look at your choices and see what answer you could come up with. So let's start from D and work our way backwards. A train moving along a flat track. So now you need to know what parabolic motion is. Parabolic motion is like this. It's like a rainbow. So a train going along a flat track is just a straight line, so that doesn't work. Alright, a space shuttle orbiting Earth. That's just going around the Earth in a circular orbit. So that's not like a rainbow, so that doesn't work. A leaf falling from a tree. Well, it could go straight down if there's no wind. So the best answer is a stone thrown into a lake. When you throw the stone, it's going to have this motion. you're going to send it at an angle that has an up and to the right component. So a stone thrown into the lake has parabolic motion. Let's go to the next one. Alright, let's get to number 5. We have a problem. So, Harold throws a ball at 12 meters per second at a 33-degree angle. How far does the ball travel horizontally if it is in the air for 1.523 seconds? And you need to ignore air resistance. So right now I want you to find out what is important here. So list your givens right now. Okay, hopefully you were writing down that the givens are the initial velocity of the vector. The vector, remember, is 12 meters per second and 30 degrees. You were also given time at 1.523 seconds. Now, you want to find displacement in the x direction. So, you want to now think of what formulas do you know that have displacement, time, and velocity. Now, since we are given the vector velocity, and we're looking at how far it's traveled horizontally, what do you think we're going to have to do with that VI? I want you to think about it right now. Alright, hopefully you can see that the vector is at 12 meters per second and it's going at an angle. And since we want to find the horizontal displacement, we need to know what this x component is. Because this is not only going to the right with the x component, but it's going up with the y component. So you can't use 12 meters per second. Alright, you want to find out how fast is it going horizontally. So, to do that, you come down and you say, do I use so or ka? And remember, the x is the adjacent. The opposite is the y. So you're going to use ka. So, if you come over here, if you want to find the x, it's going to be the hypotenuse times cosine angle. So you take the 12.1 meters per second times the cosine angle 33 degrees, and that gets you 10.06 meters per second. That's the x. That's this right here. But that also represents the velocity in the x direction. Since we weren't told that there's any air resistance, so we can say that velocity is going to be the same all the way through its path until it hits the ground. So we're going to call that average. Now you have the components to figure out displacement. So now you have to figure out what formula has average velocity, displacement, and time. So here's the formula right here. The first formula you were taught. So average velocity, and it's going to be in the x direction, is displacement over time. So to solve it, you want to move the time over. So you have displacement by itself. So you multiply both sides by time. So now plug in the information. You were given 1.523 seconds. You're going to multiply it by not 12, 10.06 meters per second, which is the cosine angle of 12, which is the velocity going in the x direction, since we're looking for that velocity. So once you do the math, it comes out to 15.32 meters, which is the displacement. Then you have to say to yourself, how many significant figures did I start with? So the lowest number of significant figures that you started with was 2. So it has to be 1, 2, 15 meters. Alright, let's go to the next one.